Fabric becomes most valuable when blockchain activity triggers real business action. In this module, we'll follow events from smart contracts into APIs, brokers, analytics, and enterprise applications, turning isolated transactions into automated, compliant, production-ready workflows. We've already built the foundation: Fabric networks, transaction flow, confidentiality, chain code, data models, access control, and client integration. Now we'll connect those skills to enterprise systems by turning committed transaction outcomes into reliable events. After that, we'll be ready to move toward deployment and operations. In enterprise Fabric applications, a committed transaction is often only the starting point. Once the ledger changes, other systems may need to respond. Update an ERP record, alert a customer, run a compliance check, refresh reporting, or feed analytics. Events turn those ledger changes into signals, so applications do not have to poll constantly. This keeps blockchain transaction processing separate from downstream workflows, while making the overall system more responsive, automated, and scalable. Fabric events give you different views of the same ledger activity. Block events provide the fullest picture, including transactions, payloads, and read-write sets, which is useful for auditing or deep integration. Filtered block events expose summaries instead, improving privacy and speed. Chaincode events are business signals emitted by smart contracts, such as OrderShipped. Commit events answer a simple but critical question: did my submitted transaction commit, or was it marked invalid? When an application listens for committed blocks, it can receive either the full block or a filtered version. Full block events include transaction details, validation results, and metadata, making them valuable for audits, reconciliation, and off-chain indexing. Filtered block events are lighter and reveal less sensitive data, so they fit dashboards, status alerts, and simple triggers. The practical rule is to choose the smallest event stream that supports the business need. Smart contracts can also emit events during execution, translating a transaction into business language. After create asset write state with put state, it might call set event with AssetCreated and a small payload, such as the asset ID and status. That signal helps applications react, but only after they confirm the transaction was committed. Treat these events like governed APIs, use clear names, manage version changes, and avoid sensitive or bulky payloads. Endorsement does not make a transaction final. It only proves that peers simulated the proposal and agreed on the result. The transaction still has to be ordered, validated, and written to the ledger. Commit events are the client's confirmation point. They report whether the transaction committed as valid or was rejected as invalid. Only after that should an application update external systems while handling timeouts, retries, and errors cleanly. Reliable event consumption starts with one assumption: failures will happen. A consumer should record its checkpoint, usually the last processed block or transaction, so it can restart safely. It should also be idempotent, because replay may deliver the same event more than once. For recovery or audit, replay from a known block and rebuild state safely. A strong pattern is to land events into a queue or stream first, then let business processing run independently, so outages do not lose signals. In many enterprises, Fabric does not connect directly to every application. Instead, an event listener captures block or chain code events, normalizes them, and publishes them into integration middleware. A broker can fan events out to multiple consumers. A stream platform adds durable replay, partitioning, and high-volume analytics ingestion. Queues work well for distributing background jobs across workers. Across all of these patterns, governance matters. Stable schemas, versioning, and ownership keep downstream systems compatible as events evolve. Fabric rarely stands alone in an enterprise solution. An API gateway should expose controlled business services, not raw peer internals. An ESB or process engine can coordinate legacy systems, transform messages, and manage long-running workflows. Microservices own focused business capabilities and react to Fabric events. The key design choice is interaction style. Use REST APIs for commands that need request and response, and event streams for asynchronous state changes across the ecosystem. Consider a supplier shipment confirmed event. Once the Fabric transaction commits, an event listener captures it, but enterprise systems should not consume raw chain code payloads directly. An adapter translates the event into a standard business schema and publishes it to a broker such as Kafka. From there, ERP updates inventory, CRM triggers customer notifications, analytics refresh dashboards, and compliance records evidence. Observability tracks latency, failures, retries, and end-to-end processing status. Ledger events become useful when they are extracted with a clear purpose. Start by selecting the minimum data needed for a report, dashboard, or model. Then mask sensitive fields, apply access rules, and move trusted data into lakes or warehouses. From there, teams can produce operational metrics, reconciliation views, and business reporting. AI models can also flag unusual patterns, fraud indicators, or process bottlenecks. The goal is intelligence without expanding privacy risk. Privacy-preserving analytics starts with a simple rule. Analytics must not bypass Fabric's confidentiality model. Extract data only from channels and private collections where the organization has rights. Before exporting, reduce sensitivity with hashes, identifiers, masking, or aggregates. Then protect downstream datasets with access control, encryption, retention limits, and audit logs. Finally, validate the pipeline against regulations, especially data minimization and purpose limitation, so insights remain useful without exposing raw transaction details. Many Fabric integration failures come from treating the network like a normal database or message broker. Keep peer internals behind an application service or gateway. Put sensitive or mutable data off-chain with hashes or references on-chain. Give consumers stable contracts, not direct dependencies on chaincode structures. And design events as a recoverable stream. Checkpoint progress, replay from blocks, and make handlers idempotent. These choices reduce security exposure, compliance risk, and production fragility. The big idea is that Fabric events turn blockchain activity into enterprise workflows. Reliable consumers depend on checkpoints, replay, idempotency, schemas, and observability. Integrations with APIs, brokers, microservices, analytics, and AI must also protect privacy and compliance. Next, we move from integration design into deployment, DevOps, and operations.